Live from the Key TV studio to your TV and on the web, it's Homework Hotline. Go to homeworkhotline.tv to ask your math or science questions.
Science at St. Bernard's Academy.
And my name is Reada McConnaughy, and I teach math with Northern United-Humboldt Charter School, and you're watching Homework Hotline.
Yeah, so welcome to the show. You can watch us now if of course you are watching us now, but if you want to see us the live stream, just go to homeworkhotline.tv. From there, you can either click on the live stream, or you can also send us a question by clicking on the link. Either an email, there's also a phone number on there, 497-5044, and you could call that number and ask your question, and I believe they can send a picture of your question if that makes it easy enough.
That's nice option with the email is attach a picture of your question, and then we can help. Math or science questions?
Any grade level, we will try at least.
In the meantime, we'll do some science with bubbles.
More stuff about bubbles.
Yeah, we did bubbles on Tuesday, and now we have some more.
So Rita's going to try to make a big bubble here.
A big bubble? I just think this is fun.
Bubble.
Look how it goes back and forth. All right, so you want a big bubble? Okay.
Right.
Whoa!
Oh, that was pretty awesome.
That was pretty
good.
good.
Almost made it completely.
Almost.
Anyway, so we were asking about why, actually,
oh, we have a quick question from last week.
Yeah, we had a question from last time. One of the questions,
Tuesday.
right when we left the show on Tuesday, somebody asked a question, why does soap create bubbles? And actually, it's not a super easy question. It's kind of tricky, and you can get really scientific, really close up about it. Soap makes bubbles because soap is actually the same reason why it cleans things. So if you get your clothes dirty, you want something that dissolves. A lot of times the things don't dissolve in water. Some things will dissolve in oils. Oils don't dissolve in water very well. So soap has part of the soap molecule has a part that dissolves in water really easily, and part of it doesn't dissolve in water really easily. It dissolves in oils and things like that. And that's why you can clean dirty things with soap.
Because the soap will attach to the dirt and then move it away.
Yeah,
right?
and attach to the water. So it's really great that way.
But why bubbles?
Why bubbles? Well, what happens with soap, and I was describing this last time too, is that actually on a bubble, the soap will form two layers of soap with water in between it. So there's water in between. So a bubble itself is surrounded by a layer of soap, and then a layer of water, and a layer of soap. And so the layer of soap, the part that doesn't want to be around the water, is facing outward and also inward towards the air. And so when you shake it around, you make a lot of little bubbles like we're making in that little pan. It's because the soap is just forming around the air and it's trapping itself in there. So why it forms a bubble is that pretty much there's this elasticity around it that's kind of forcing itself inward. And like anything, it'll form a sphere because it's the least amount of surface area, but for the amount of volume that's in it. We'll always form a sphere. You'll never get square bubbles or triangle bubbles or flat bubbles.
I think I like these bubbles.
Yeah, just like you won't ever get once it forms a bubble, you've got air trapped inside of there, and there's a certain volume of air, and there's the bubble forms this elastic shell around it, and that shell will shrink to whatever size.
Trying to get it to, okay.
To whatever size it is, so the smallest amount of surface area for the amount of volume that's in it. And then
look at that.
They're very nice.
Huge.
Oh, come on.
Oh.
Anyway, so that's why things will form a sphere. This elasticity will shrink down to it, and it's the least amount of surface area for the amount of volume is a sphere. That's why you always get a sphere. That's why you'll get a spherical bubble. You won't get a flat bubble. It's the same reason why we won't get a flat Earth. Going to be a sphere because it makes the least amount of surface area for the amount of volume.
Maximum volume, minimum surface area.
And things will naturally do that all the time. That's why you blow a bubble underwater, it'll be a sphere, unless there's some kind of force pushing it and makes it slightly like we saw those bubbles wobble a little bit because there's a lot of air on it.
I had a great thought about maximum volume. You know, like ice cream, they put them in like little balls sometimes. Is that like maximum volume?
For the amount of space?
Yeah.
Sure.
Okay.
I mean, that's what a sphere is.
Sorry,
I don't know
total
if-
random thought because we had an ice cream discussion today in math class.
but if you did, it's like if you put the
Sphere.
same volume of you had the same in math class. If you had a certain volume of material, and you wanted to minimize surface area, you always will want to put it into a sphere. So you can even try to do it with a cube or something like that. You'll find out that there's more surface area on the cube than there would be on the sphere.
Gotcha.
And things will naturally take that kind of shape. So there's some other things you could do with the bubble soap. And I thought we had this laid out here. I could try to blow another bubble on the table, make a table bubble, and then put a little something around it so we could play around with that.
Okay.
All right, ready?
Yeah, sounds good.
Okay.
And when he was practicing these, they turned out beautiful and big. He's just got some bubble solution on here, and then with the straw, trying to make a great big bubble. On Tuesday, we measured the circumference and the diameter and got pi.
And what's fun, you can take a little piece of
But today we're
paper
going to
and
look
put
at
it around it, and we'll see if this works. But you can see with the lights in here, you can see. I think we can see some colors.
So
We
if we
shine
look
that
at
down from
the-
the mirror.
get a top view.
Top view of it.
There we
And
go.
Pretty good, and you can see. Actually, it's lensing the black underneath it as well.
Oh, it looks like an eye or a marble.
And if you blow on it, I know you can get some pretty good colors going. Just because it's the white light is reflecting around, and then it finally pops. And so you can play around with this at home, and then watch the surface of the bubble, and watch to see if you can predict when it's going to pop, because it will change the colors. The swirling colors will change a bit as it's getting closer and closer to pop. So
Cool.
we can try that.
Do you want?
I'll try it again.
Okay.
And then
In the meantime, looking good. Looking good. Okay, so you said you can tell when it's gonna pop, right?
well, I can't. I know it's changing. Can you tell when it's going to pop? Is the question.
Oh.
And I don't want to. Can you start seeing pattern in when it's about to pop and when it's not about to pop, or what does it do right before it pops? And you can see the color patterns will go on it. Will change a little bit as it goes. And I see
Oh,
some
it's starting
purples
to
and some
change
greens
and move.
and swirl.
Oh, I blew on it.
Yes, it will definitely pop if you blow on it hard enough. Another question, actually, I can go to a question too.
Sure.
Another question that was asked right before the show ended yesterday is changing gears here.
Sure,
What's a somatic cell?
Okay.
And I think somebody asked that question if they're watching again this time. Somatic cell is just a body cell, and I think it probably has to do with genetics. The question is like how many copies of the chromosomes are there? What is a somatic cell, and why does soap create bubbles? I started with the second question. Somatic cells are body cells, your regular body cells. So like your skin cells are somatic cells, and muscle cells are somatic cells, and nerve cells are somatic cells, and all the cells that line your intestines would be somatic cells. And those have 2 copies of your chromosomes in them. So a double set of chromosomes, one from each parent. You get one set of chromosomes from your mom, one set of chromosomes from your dad, and they are all both sets are in your body cells or somatic cells. So you have the double set of chromosomes. So those would have 46.
So when they do DNA testing, do they look at the
They look-
somatic cells? And
They would typically look at the somatic cells with DNA testing, because that shows where both parents came from, or what the genetic information from both parents.
go up and down.
Okay,
Okay.
so
I'm
yeah, if
just
you have any
playing.
other questions, give us check in with us.
Math or science questions? Homeworkhotline.tv.
And so we talked about you can make your own bubble solution, right?
Yeah.
So you don't have to go. You could go out and buy bubble solution for a few dollars or whatever, but you don't have to. You can make your own, and there's a lot of different recipes you can find out there. I just use I use about 6 for every 6 cups of water.
So
I use a cup of dish soap. So 6 cups of water, 1 cup of dish soap, and a tablespoon to 2 tablespoons of glycerin. And glycerin is something you can buy at a number of pharmacies and things like that. Sometimes regular stores will have it, like supermarkets might have them too. But glycerin, you'll find it usually in the skincare section. Glycerin.
Skincare, because they put it in moisturizer, right?
Well, I mean, yeah, that kind of thing is what you, for rough, dry skin. Dry skin, you can use it for that. So that works. That actually helps the, you don't have to have it, but it helps the bubbles get bigger, and it helps the bubbles, it helps that soap layer. It kind of strengthens it so the bubbles can get bigger and it can last longer, so the water doesn't evaporate. So that's when the bubble pops, is when the water that's in between the two layers actually evaporates. And goes away. Yes, that's why it pops.
Changes form.
That's right.
Right? Water evaporating, changing form?
Changing from liquid to gas.
Okay.
Yeah, going away. Yes. All right. So, and then most dish soaps can work, and you can play around with how much glycerin makes the best bubbles and makes the ones that last the longest.
And when did you make this solution? Because you said as the solution sits for a little while, it gets better.
I made that stuff on Tuesday, and so now I think it's working a little bit better today than it did when we were first playing with it. Let's do this. Other things you can do. I mean, you don't have to. You can get bubble wands, but you can also make some things out of straws and string.
Okay.
So here you go. You want a bubble window?
Yes.
Here's a bubble window for you.
Thank you.
And then I'll have a bubble window.
Do we make bubbles out of it, or is it just...
You can just look through it and things like that. The fun thing about bubble windows too is that you can also, maybe you can put your finger through it.
Oh.
Can you do that without it popping?
Without it popping. Oh, mine popped.
No, I cheated because I put bubble soap on my fingers. So it
Oh.
helps you put some bubble soap. And again, if you're playing around with something like this, it's nice to go and do this slow motion.
No, I think I need to come over there.
Work really slowly with it. Just lift it out slowly and it'll come up.
And this is string and straws?
String and straws. That's all it is. And I tied it and I put the little knot in the middle of the straw.
I think I tried to make a bubble on this one, right?
You could.
On Tuesday. Whoa. Okay.
Wait, let's see if we can we put my bubble in your bubble?
Okay.
Let's see if we can put a bubble. Whoa, that's crazy. Okay. If you work, and it's a lot of tension. That's pretty crazy. If you just work slowly with this, it tends to work a little better. So I'm going to lift it out slowly. And let's see if I can put my window into your window.
So, what?
Oh, mine went away. That's not going to work.
It might be hard to see this on TV. Oh, mine popped too.
All right. Okay.
Oh, okay. I'm kidding.
Okay, there we go. I'll try it one more time. If it pops, we'll try something.
It
Mine
popped.
popped. Mine popped
Darn.
too. But you can have hours of fun with this, or
Trying
at least 30 seconds of fun with this.
I could see this be done outside, right? That's really cool.
It works. You can work outside as long as it's not too windy.
That's right.
If it gets kind of windy, the bubbles don't work as well.
Gotcha.
So that's another thing we could do. So how big a bubble can you make with that?
Well, how big do you want it? Like over your head, big? Would you like a shower?
Absolutely.
Okay.
As big as you can. Well, I set up this next thing.
Oh, look at that.
That was awesome.
That was really cool. Okay, so you're going to...
All right, here's another. This is similar to bubble windows, except we're going to have a big window now. We're going to have a bubble screen. Now, this one I just took some, again, string and a dowel. And
What's a dowel?
This is a
Like
dowel
a
is that piece of wood, a round piece of wood, and a couple of washers on the string, so they stay down. So I'm going to put the washers off to the side. And this is a tray. This is a wallpaper painting tray. So you can get them at a paint store, a nice narrow one. And then we can just lift this up slowly. And now I have a bubble screen, and that is really there.
And then I see the colors changing.
Yeah. And then it's still there. It really is there. If I blow on it.
Oh.
Yep. Pop. Then again, if you get your hand.
Why does sometimes it pops and sometimes it goes out?
Because I guess
That's
just enough of it evaporates on the inside, I guess.
Okay. And so hand through?
Well, yeah, get your hand a little bit soapy
Okay.
first and see if you put it through. Yep.
Oh, darn. Okay, so hand soapy. I wonder if we need to turn it sideways. Is it easier to see the bubble if it's sideways?
Try a little
Okay.
sideways.
All right, here we go. Soapy hand. Oh.
You got part way through. Let's see.
Okay.
Try it.
Maybe you're better at it. You want me to do it?
I don't know.
You're better, I bet.
No, I don't care. My hands are gonna get super soapy. 'Cause that's what's the thing is about this. Is when you play with bubble soap, you clean your hands. That's what happens. You get super clean hands, and you can say
Nothing
to your
wrong
parents,
with
"I
that.
want to clean my hands really well today. Can I play with the bubble soap?"
Or I would say you should ask first, right?
Certainly. But part of your
Okay.
asking could be the thing. Okay, here we go.
The bubble's still there. Whoa.
That's pretty good. One more try, and then we'll do
Okay.
something else here.
So some washers holding down the string, the wood dowel.
And then
Right.
if you pull it up, then the string gets the tension on the string pulls it apart enough.
Okay, so don't let tension get.
Trying to
Best
get
of ya.
the screen to wrap around it.
Okay,
It's going.
here we go. All right, soapy hands going through the bubble.
Oh, great.
Where's our bubble sound
Okay.
effect? Blah, blah, blah.
Well, hey, we got some science questions.
Oh, good deal.
Okay, it says, I think we have 2 of them.
Okay,
All right. I guess
Here.
that's on me.
here you go.
What can cause things to change from a liquid to a gas? So liquid to gas means it goes from, well, liquid to gas is a state change, right? Usually that means there's some energy getting added to it. And so liquids are molecules that are moving kind of closely to each other, and they are pulling on each other in some ways, and they're in liquid form. And so when they go to gas, they go out and they're spread out. They have a lot more kinetic energy when they're gases usually. And so they'll be flying around. So you usually have to add energy to the system somehow. And we have things going from liquid. Water is something on our planet that we can find in solid, liquid, and gas. And so it goes to gas. One way you get it to go to gas is to boil it, right? That's get it up to
Get
100
it
degrees
moving really
Celsius.
fast.
And then they move fast enough, and then the water molecules will come off of there and go into gas. But gas, it's also happening all the time.
Steam, right? That would be steam.
Steam would actually be it's still very hot liquid water, I think, but it is steam. Steam is when it becomes evaporated completely goes into, yes, it goes
Okay.
into gaseous water. And this also happens with evaporation as well. Just even temperatures that are less than 212 Fahrenheit or 100 degrees Celsius, water will go right from liquid to gas as well. And they'll go
Nice.
right up into the atmosphere, and that's why we get clouds forming after it condenses again. But that's what causes. Usually there's some kind of energy getting added to it, to the liquid that gets us to go up to gas, and that's what happens.
How about going the other way, gas to liquid?
That's condensation, and that's what happens in the clouds. It gets up there high enough, it cools down enough, and then the air can't hold as much water, and it condenses, and it condenses into clouds. Clouds are actually not gaseous water; they're liquid water. It's little tiny droplets, and if you get enough of them combining together, the fluid air can't hold them up anywhere, and they fall down and has precipitation. Is either
That's-
rain or snow.
That's really neat.
Yeah, water cycle. It goes back again to around and around. And we even got another question.
Yay!
What's
Another
the-
science question.
What's another science question? You're going to make me busy, but that's okay. What is the difference between mitosis and meiosis? And I'm guessing this is from some of my biology students who are studying this right now.
Is it a toe?
Well,
Just kidding.
mitosis does happen with your toes.
Really?
It's just mitosis means a cell division where it's an exact clone of the cell. So it's dividing. So a developing embryo will divide by mitosis before it differentiates, or actually even after it differentiates, but when it starts. So makes one cell that turns into 2 exact copies of the cell. So your skin cells are doing this. Every time you lose some skin cells, you have other cells that replace it by mitosis. That's what's happening. So when you make a clone of a cell, you're making its mitosis, and it has the same number. If you started off with 23 pairs of chromosomes, you end up with 23 pairs of chromosomes with your new cell, and so 23 pairs. So there's 2 copies of each one. In meiosis, it's 2 divisions. There's, like mitosis, very similar, but there's two cell divisions, and it happens with the gametes, with sex cells, because in meiosis they'll divide up, and so the gametes only have one copy of the chromosomes. So there's a division of chromosomes, and then there's another division that happens, and so that's going to be the difference between the two. Is that it's a reduction division as well. So it's reducing the amount of chromosomes.
What kind of science class would that be in?
That's in a biology class, or sometimes students will learn it in seventh grade science as well. Seventh grade science, mitosis, meiosis usually, and then in beginning biology as freshmen, and you take a really close look at it in some more advanced biology classes as well. So
cool.
Typically they'll learn a bunch.
Cool. You have another science question. Wow. What is the parthenogenesis?
Parthenogenesis.
And how does it relate?
Parthenogenesis, and how does it relate to meiosis? Oh, I've got a blank on that one.
I don't know.
Parthenogenesis. That's our
something parentheses?
I don't know if that's being.
I don't know.
Parthenogenesis.
Well,
we'll have to look at it.
Yeah,
I'm not sure on that one.
We'll have to peek at it.
We'll have to peek at it. But meanwhile, I'll get to that one in if I can.
We'll try to come back to that before we're done.
Yeah.
Okay. You have a bubble.
I have one more thing
one
for
more
bubbles
bubble?
here.
Okay.
And it's going to be stacking
move
bubbles.
This off?
Yes.
To the side?
Yeah. Let's put it off to the side. We'll put this one in front.
Okay. This is fun. Got it? Okay. Do I need my straw for this one?
Yes. Put your straw on the side.
Okay.
Okay. And then here. Oh, actually, no. I already put yours is still on there from before. Okay. This is okay. So I made this with a couple of plexiglass plates. Put it in between some wood, and we put it into the bubble solution, and we're going to blow bubbles into it.
All right.
Ready?
Yeah, I think so. I'll try. Oh, mine's not in the.
You have to kind of. I guess we can push it down a little bit there. Hold on.
That won't reach.
Here, how about this? If you hold that up, we can. There you go. Maybe that'll work. Okay. Well, I think it'll work from just with one side.
Okay, you might have to do it. This was really neat. The bubbles are forming between the two glass. You said this is forming a honeycomb?
Well, it's
similar?
stacking, so we can see what kind of shape we can make with this. Stacking bubbles.
Oh, there's a great big bubble in there.
Oh yeah, we could.
There we go.
So what kind of shape is it forming if they stack together?
Well, how many sides? 1, 2, 3, 4, 5, 6 sides. So hexagons?
So how do most of the bubbles?
1, 2, 3, 4, 5, 6. They're not like regular hexagons where everything's the same length.
Right, but they are pushing up against each other. When the bubbles all push up against each other in that particular way, they typically, and it's funny, there's a big gap in the middle there, but
I know, it's like a
they
great
typically will
big.
form these. Usually you'll get hexagons out of it. And this ought to remind you of something.
Can you see the
Oh, there's the thing about yeah. It's just one form anyway, so it's
one form of meiosis?
yeah, one form of reproduction.
Gotcha. Of cells. Oh, the bubbles are coming up and over.
That's right. But yeah,
And then when they come out, they're more spherical.
right. But since there's something pushing up against the side of them, we get them.
We made our
pressing
own
each other.
bubble making machine.
That's right. So you might think about what the shapes in here that if you look into a beehive, and you'll see this honeycomb shape, and it's just because it's liquid, pretty much liquid bubbles pushing up against each other, but they're wax things, bubbles pushing up against and being compressed,
That's
and so
really
they'll
cool.
naturally form a honeycomb structure. So the bees aren't making honeycombs. This will naturally form.
How did I not know that?
I don't know. Didn't know it either. I wouldn't think it either. It's just when circles press up against each other and all the forces are about the same, then they tend to.
All right, this was fun.
Wait, one a little bit more.
I think one of my favorites. Would you like that shower now?
Yes.
Whoa!
That was a nice one. And then you could do the oscillating bubble. You have a bubble wave.
The bubble wave is one of my faves. Whoa. Just kidding. Well, thanks for watching, you guys. Have a great day.
The bubble. The bubble thing. Okay, so.